Welcome to my lecture on trigonometric integrals. The first type of integral that we're going to try and evaluate is of this form. It's sine to a power of x times cosine to a power of x. Okay, and we're going to deal with several cases. Okay, so our first case is as follows. So this is going to be case 1. And in this case, the power of cosine is odd, okay? So odd powers are like 1, 3, 5, 7, 9, and a general formula for that would be if n is equal to 2k plus 1. If k is 0, n is 1. If k is 1, n is 3. If k is 2, then n is 5. So all the numbers I said, 1, 3, 5, 7, etc. Okay. And in this case, let's work out an example. Okay. And let's integrate this sine squared of x times cosine to the fifth of x. Okay, so this is going to be our general strategy. We're going to save one factor of cosine. And we're going to use the identity that cosine squared of x is equal to 1 minus sine squared of x. Okay, so i.e. we're going to do this. We get the sine squared of x times cosine to the fourth of x times cosine of x. This is the factor that we saved, so we're not going to do anything to that. But we are going to use the identity here. Okay, and remember, via the identity, cosine to the fourth of x is equal to cosine squared of x quantity squared. So now if we plug in the identity for cosine squared, we get cosine, excuse me, let me erase that. We're going to replace cosine squared by 1 minus sine squared of x times, but that quantity is squared, so we'll have that squared, and foiling this, we'll have 1 minus 2 sine squared of x plus sine to the fourth of x. And we're going to use that identity. Okay, so we write this integral. We have sine squared of x. And instead of having cosine to the fourth of x, we have this equivalent expression. Okay, and now our last strategy is to do a u substitution. Okay, so from our general strategy, Okay. We're going to let u equal to the sine of x. Okay. Then keep in mind the derivative du dx is going to be equal to this cosine of x. Okay, so du is equal to cosine of x dx. Oh wait, that happens to be precisely what we saved right here. This is du, okay, because we have it from this identity right here, okay. Now let's replace the signs by u's. So this is sine squared, so that should be u squared, times by 1 minus 2u plus 2u squared, I apologize, plus u to the fourth times du. Now these are a single variable of u, so we know from calculus 1 how to integrate this, especially if I FOIL this u squared term. So if I FOIL, I'll get u squared, that times that, minus 2u to the fourth, this times this, then this times this is going to give me a plus u to the sixth du. Okay, and we just anti-differentiate this. This will be 1/3 u cubed minus 2/5 times u to the fifth plus 1/7 times u to the seventh plus a constant of integration. Now I started with something in terms of x, so let's finish with it in terms of x. Well, we just back substitute. U, after all, is going to be sine. So this is going to be sine cubed of x plus 2/5 sine to the fifth of x, and that should be a negative. Plus 1/7 times sine to the seventh of x plus our constant of integration. Okay, so that's an example of integrating a trigonometric integral in which we have an odd power of cosine. So once again, I'm just going to state our general strategy. Okay, so you should be prepared to be able to integrate something like sine cubed times cosine to the seventh. Different powers of cosine, different powers of sine, so long as the power of cosine is odd. And here's the strategy if the power of cosine is odd. So general strategy is first, save one factor of cosine. Second, use the identity that cosine squared of x is equal to 1 minus sine squared of x. The integral should now entirely be in terms of sine. Okay. Third, you're going to perform a u substitution. Okay. So your u substitution is u is equal to sine of x. Then fourth, integrate. Okay, and I'll put dot 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 because integration is going to involve some extra steps, but this is your general strategy, and this is your first example of a trigonometric integral. In my other videos, we're going to deal with when the power of sine is odd, for instance, or if both powers of sine and cosine are odd. So we'll be able to integrate any form of sine to a power of x times cosine to any power of x. But this was one particular instance. Watch the rest of the videos to see the rest of the instances.